So today we're going to talk about section 5.5 in our Algebra 2 book, which is applying the remainder theorem and factor theorems. So what we're going to do in this section is we're going to be dividing our polynomials to figure out what our zeros are, figure out what our zeros are given one of our zeros. So we're going to just be doing some division. So let's take a look. First way we'll look at division is standard long division. For some problems you are going to have to do long division. You won't be able to do synthetic division. So let's take a look. Well, we'll set up just like we would normal long division way back in the day. We'll have our x minus 2 on the outside. We'll have our x to the third plus 5x squared minus 7x plus 2 on the inside. We're always looking at our first term. So first we're always going to be focusing with that x. In this case, that x to the third comes first. So we're seeing how many times does x go into x to the third? Well, x to the third divided by x is x squared. So we'll put it above our x squared just to make sure everything lines up, and multiply. So x squared times x is x cubed, and then we need to distribute to our other part. So x squared times negative 2 is negative 2x squared. Just like with long division way back in the day, we are subtracting all of this. So x cubed minus x cubed is 0, as planned, and 5x squared minus negative 2x squared is 7x squared. We'll drop down our next term, and then, again, we're going to look at this 7x squared in our x. So 7x squared divided by x is plus 7x. We'll multiply. So we have 7x squared minus 14x. We're subtracting all of this. 7x squared minus 7x squared is 0. Negative 7x minus negative 14x is positive 7x plus 2. Bringing that 2 down. 7x divided by x is plus 7. Multiply, so we have 7x minus 14. Again, we're subtracting all of this. That drops out. 2 minus negative 14 is 16. Now we don't have anything else to drop down. So whereas you might have at some point in your life done R16, we're going to do plus 16 over, well, whatever we divided by, x minus 2. So that is our remainder. And this is our solution. Now let's look at a problem where we have a term missing. So just like we did with synthetic division, we are going to have to put that placeholder 0, and really it's just to make sure that you don't subtract unlike terms. If you really don't want to put it, fine, just be careful and don't make me tell you I told you so. So let's give it a shot. We see that we are missing an x squared, so we're going to make sure that when we have our x squared in our quote-unquote house, we are going to make sure that we have a 0x squared. So we're just putting our whole x squared plus 2x minus 1 on the outside. And then we have 2x to the fourth plus x cubed plus 0x squared plus x minus 1 on the inside. Notice how it is a little bit long, but we'll get through it. So just like the other one, we're looking at our first terms. 2x to the fourth divided by x squared gets us 2x squared. So I'm going to put that above my placeholder x squared. So we've got positive 2x squared. We are multiplying. So 2x squared times x squared is 2x to the fourth. Multiply with the 2x. So we have plus 4x to the third. Multiply with the negative 1 minus 2x squared. Now again, we are subtracting all this, especially just because I have the 3 terms right here. I'm just going to distribute my negative right away so I don't miss it, and that way it's a good strategy for you not to miss it as well. So now we can just add, those go away. We have negative 3x to the third, and then positive 2x squared. We're dropping down our x. Looking at our 3x to the third and our x squared, so negative 3x to the third divided by x squared, we have minus 3x. We will multiply through, so we have negative 3x times x squared, so negative 3x to the third minus 6x squared plus 3x. We are subtracting, so I'm just going to multiply that negative 1 through. Those drop out. We have 8x squared and negative 2x minus 1. Now we've got 8x squared, x squared. When we divide them, we have 8. So 8x squared plus 16x minus 8. Multiply my negative 1 through. So I have negative 18x plus 7. Now when I take negative 18x, I can't divide into it x squared, so that's just for my remainder. So plus negative 18x plus 7 all over x squared plus 2x minus 1. Good news, for some problems you will be able to do synthetic division, which is far less work and less room than long division takes. You just have to make sure that your divisor is in the form x minus k, so then we'll use that k as our outside number. And we'll do synthetic just as we normally did, making sure we have a placeholder if we need one. So here I have x plus 3 as my divisor, so I'm going to use negative 3 as my number on the outside. Coefficients in order, so 2, negative 1, negative 8, and 5. I did not need to have a placeholder because all of my powers were there starting at that x to the third. Drop down. 2 times negative 3 is negative 6. Add. Negative 1 plus negative 6 is negative 7. Multiply. Negative 3 times negative 7 is 21. Add. 21 plus negative 8, which is 13. 13 times negative 3 is negative 39. Adding, and we end up with negative 34. That's our remainder. So we have to make this look like our answers did in the previous ones. So that's our remainder part. So we have minus plus negative 34 over x plus 3. You could put a minus sign there, but sometimes when you have something longer, you just have to be careful to make sure that everything lines up properly. So 13 is going to be our constant, negative 7x, and then 2x squared. So I was just working backwards, starting with my remainder, and going by terms of powers. So starting with x to the 0, x to the first, x squared. Again, you can only do this if your divisor is in the form x minus k, x plus k. You're just making sure that you can get a single number out of it. Now the remainders. If the remainder is 0, the divisor is a factor of the dividend, and we can use this to help us factor more complex polynomials. So we'll have 5 terms in our polynomial, but we'll still be able to factor it because we can use our idea of the zeros. And sometimes they'll tell you a factor such as x plus 3, or a 0 such as negative 3. And from there you'll use synthetic division until what remains factors for you. You can keep going with the synthetic division until the very end, but once you see something that factors, usually it's easiest just to factor. So we have factor f of x equals 3x to the third minus 4x squared minus 28x minus 16 if x plus 2 is a factor. So from this, I know I'm going to have negative 2 as my number on the outside. So I'll set up my long division. I notice I am not missing any terms. So I have 3, negative 4, negative 28, and negative 16. So I should have a remainder of 0 because I am told directly we have a factor. Drop down our 3. We have negative 6. Then we have 20. Then we have 16, and when I add, I do have that 0 that I was expecting. So let's see what I have here. I have 3x squared minus 10x minus 8. Let's see if that factors. Can we get a product of negative 24 and a sum of negative 10? Well, looking at this, I see that if I do negative 12 and 2, I can get it to work. So I'm going to make my box. You can use whatever method you feel best. So from here, I know my other factors are 3x plus 2 and x minus 4. And then I have my x plus 2 from my beginning. And lastly, if we're given a 0. So we just put that 0 right on the outside. We have a coefficient of 1, negative 2, negative 23, and 60. Again, we're told it is a 0, so we should have a remainder of 0 when we put in our 3. So we drop our 1. We multiply, so we have 3. We add 1. 3 times 1 is 3. We add negative 20. 3 times negative 20 is negative 60. And we did get that 0 as promised. So we have x squared plus x minus 20. Well, let's see if that factors. And I know that can factor to x plus 5, x minus 4. So from these binomials, I know my other zeros are negative 5 and 4. And that is all. We'll work on this more in class, and I'll see you then.